I was on mute. So before you record, you have to let people know you're recording. So guys, I'm recording. I'm recording the class. If you have any issues with it, feel free to let me know. So I'm going to record it from now to the end. Anyways, so to talk about what happened last class, when we supposed to have class. So I was actually at the store trying to buy, and I got a notification on my phone saying one of our production systems was down. And this is essentially our main, it's like our main API system, right? So for our data, so this system connects to our Postgres database, and it acts as a front API. So basically, people can connect to that instance and pull out reports, right? People can connect to that instance and pull out some valuable information, data and stuff. So it went down. So I had to get there. So I'm on call. So this week I'm on call. So usually I'm supposed to be the first respondent to everything this week. So I told him I head back, and then we get on the system. And the first thing I do is, because that system, when I came here, one of the first tasks I did was to move that production system to another Kubernetes cluster. So I'm very familiar with it. So I got in there real quick, and I looked at the pods to see if they're running on Kubernetes, because Kubernetes has something we call pods, which we're going to talk about. So I look at the pods. The first thing I do is I look at the pods, and it seemed like they were running, right? And then I described the pods, and it seemed like, everything seemed okay from the outside. And I was like, this is not okay. So I pulled out the service using kubectl get service and the namespace. It gave me the load balancer, so I tried to contact the load balancer, and nothing. So I knew something was up with that, with the actual pods, because they were deceiving me pretty much that they were running, but they were not. So I took kubectl get nodes to get whatever system that the pods are running on, right? And I was getting instances that they're not ready. They're not ready. They're not ready. And if pods are not ready with Kubernetes, what happens is Kubernetes schedules pods for Docker images. So, but if there's no node for Kubernetes to schedule those pods, then the nodes are going to be left hanging. It's pretty much like you're in the air just waiting to have to have your own shot.
Yeah. Okay. Linus, I have a question. I was having problems downloading the stuff. I don't know if you can still put it. Why most people haven't come now? Let me see if I can download it again.
Well, it's gonna take too long. You're using a Mac, right?
No. I'm using Dell.
Well, that's gonna take too long. We have already. I told you if you have issues, you have to contact me before class. But it's gonna take too long.
Did you see my missed calls? I've been
calling you. This dude called me at 6 a.m. in the morning.
That's okay. Anyways, I'll call you on Sunday. Maybe on Sunday after church in the evening we can do it.
Only before 5 a.m. though, okay?
No. I'll call him in the evening, like in the evening on Sunday, Linus, because I'm still having that problem.
Yeah. So the link, I shared the videos on it. If you go to those videos, the link are right underneath. So for the video we're doing the installation, right? If you look underneath that video, the description, you will see the link to the CentOS file and also the link to the slides. So everything is there, bro. Like you can just follow that video and you could just download that link. It should be good to go.
So you say, where is the link?
I shared it on the group chat. I could put it out right now. But yeah, anyways, guys.
Please.
Please. So I think we have a decent number. We should be ready to start. So I could post that. Let me put that YouTube link. Real quick and see if I could.
Yeah. Or maybe I should send you my email. You just send it to me. But anyone that works, you can do anyone that works.
So it's basically my the channel link. So it's a link to a playlist that each time I upload a video, it's going to automatically be added to that playlist. So let's see. So anyways, this is, I'm posting in the chat. This is one of the links, but yeah, I have the actual link. If you just go back to the chat, good thing that chat doesn't have a lot of message. So if you go to the chat, just scroll a little bit up, you're gonna see a link that I posted. So yeah, we should be good to go, guys. So we're gonna start. We're gonna get right to it, guys. So anyway, I was talking about what happened. So what happened was, we have, whenever you build a Kubernetes instance, usually we have something we call managed nodes, and you have something we call unmanaged nodes. So the managed nodes are actually controlled by the control plane. And then the unmanaged nodes is what you manage by yourself. So which means that if you mistakenly deleted that Kubernetes cluster, those nodes are still going to be there. They're going to run like offer nodes. Per workload, you still have your workloads running on it. So there's this role that you give to your what we call, when we talk about Kubernetes, it makes more sense, but it's called kubeconfig. So there's a kubeconfig file that you put a certain role in there. So whenever you have an issue with your system, like your nodes, it's going to auto scale. So it will kill the old nodes and rebuild new nodes, right? And then those nodes will be able to join that cluster, and then your work, everything continues like it never happened. But essentially, that role was missing, but it was there previously. So we had to find out what was happening. And we had one of our new engineers that was doing some changes on the system, and he was unknowingly kept deleting that role, right? He deleted the role. So the system couldn't scale to scale and join the group. So that's essentially what happened. We had to get AWS into it. The guy from AWS was the one that realized that the role was missing. So we added the role, and then yesterday it happened again. But we knew exactly what to do. We went in there, first thing we did was check the role. The role wasn't there. So we added the role, and I scaled the group up to 6, and then the system came back up. So pretty much, that was the issue. But guys, Kubernetes is complicated like that. So you can look simple on the outside, but there's so many things involved, like providing accesses and roles. And if I didn't know Linux, guys, there's no way I would have gone in there, because like we talked about, I know we're going to talk about VI today. Let me share my screen real quick. I think VI was the reason why I was able to go into that system and, and be able to edit the configuration files pretty much, Oops, someone's been doing shopping.
Somebody has been doing shopping.
So yeah, so I know we talked about this editor last time. So this is what I was able to use to get into the system and make changes to the configuration file. Because when you open a configuration file using Kubernetes, it comes as a default editor. Usually it's always Vim or VI. So you make the changes and you have to be able to save it, guys. And then your changes, you can go in there, edit. So this is very important. I keep telling you. And even Linux, how was I able to go in there and start running Kubernetes command? It was on a Linux machine. So everything we do is on Linux. That's why Linux is important. You don't need to be a master in Linux, but you need to be able to move around. So we're going to start real quick, and guys, we're going to get right to it. So I know we did VI last class. We talked about the different commands, guys, and we talked about how to exit programs. So the most important thing you want to know about VI is, how do I open a document or text? How can I write, and how can I save or not save? Those are the two most important things. So if you want to quit without saving, this is what you need: the colon, Q, and exclamation sign. That's when you edit and you say, oh no, I don't want to edit no more. Like, I don't want to make any change, right? Then you use escape, colon, Q, and then your exclamation, and you exit without saving. If you are like, okay, I'm fine with what I'm doing and I want to save it, this is the one you use: colon, WQ, hashtag. So W stands for write, and Q stands for quit. So I want to write and I want to quit. But the other one, the Q exclamation, is like quit and don't write on that file, pretty much. That's essentially what it is. So anyway, guys, I know we did this, but we're going to go in there and we're going to talk about that real quick. Where's my terminal? So this is my Linux terminal. I know we have a file here called a.txt. As you can see with my ls right here. So what I'm going to do is I'm going to open that file real quick using VI. So VI And if you don't have a file, guy, you can just create a file like mine by using touch space a.txt, and you create a file like that. So if you don't have a file really running, you can just create one real quick, and then you can then VI into it. So I'm VI a.txt, and see I'm back in the file. That's my editor, right? And now to write in it, what I gotta press is I as an insert. Guys, we're gonna have all this on video, and tomorrow I'm gonna upload the video in case you wanna go back. Now you press I and you let it insert. You see insert appears, and now I can start, hey, how are you? Right? I can start typing, hey, how are you? And all that stuff, any fancy stuff I wanna put. And with VI, you can also copy and paste. So you can copy from somewhere and paste in there. With this system, it might be complicated, but when you're working on actual cloud, which you're gonna be working on, you can copy from anywhere, you can paste in that VI, so it makes it really easy. So this is, hey, how are you? I don't want to save this, right? So guys, you remember, if you don't want to save this, you just quit and exclamation. If you don't want to save this. So I don't want to save this file, what I'm writing. So I'm going to hit escape on my keyboard, and then our normal colon, and then Q, and then exclamation sign, and bam, it goes. And if I cut that file, I know we all know about CAD right now to display contents. We shouldn't see anything in that file, right? You see it's empty because I refuse to save. I use the quit exclamation sign. I know everyone has access to that slide. You can open it to the side of your page because I have everything on there in case you wanted to reference. So I'm going to open that file again and put one or two things in there, and I want to save it this time. So VI, the name of the file opens, I hit insert, insert, and now it's letting me write. I say, hey, how are you? My keyboard types like a grandma. Hey, how are you? Thanks for the cake. And then now,
even showing Linus.
Sorry?
Oh, okay. Yeah,
guys, if you have any questions, just type it in the chat.
Oh, okay.
Yeah, every five or so minutes, I'll look at the chat. Thanks. And now, guys, I want to save this. I don't want to delete without saving. So I'm going to hit escape. Our colon, as you can see, colon appears down here. It might be hard to see, guys, but I hope you guys can see. And then I'm going to use a W. Oops, that's too many W's. W is Q, and then an exclamation sign. I'm telling you that I want you to write and I want you to quit when you're done. So if I hit enter, there we go. And now if I cut that same file, so if I cut that same file, guys, what do we have? We have everything I've been typing in there because I choose to save and quit. This command, guys, I can't emphasize to you how important this is. There's other ones like Nano. You can write that down, Nano Editor, which is easy to use as well. You can make it your default. But guys, when you get into IT, you want to use the stuff that the big guys are using. And trust me, if I was in IT and you came and you were a new employee and you were using something other than VI, I'm already looking at you like, damn, what are you doing, bro? In my head, I'm already judging you pretty much. In my head, I'm already thinking this guy might not know what he's doing. So this is what guys are using because it has so much functionality. You wouldn't have to use all of the functionality, but just the fact that you're using VI, you're already putting yourself in there. It's just one of those things that you have to keep in mind when you're doing IT. You don't want to be using any other easy editor. This is what you want to be using. So go, remember, and practice how to use VI. When you try to edit a configuration file, it comes in your default editor, always VI. If you want to edit a document remotely, you use VI. So there's so many uses to this, guys, because you're going to have to change configuration files. You're going to have to change documents, change things on the remote server. And this is what you're going to be using. So don't underestimate the command. Practice it, practice the two commands. The slide is there. Try using it. Practicing. I've literally used 3 commands to do what I need. Open the file, type, and save. That's what I use for the most part. You can start doing other complicated things, but type and save, or type and without saving, those are the most important things. So sometimes you type and you make a mistake, and you be like, oh, you don't want to go back and try to look for where you made the mistake. So you can just quit without saving and then open again and continue. So yeah, that's it for VI, guys. But yeah, the video is going to be available. You need to practice this command. I can't emphasize to you how important it is. This is the next one. And this next one is when you want to remove a file, right? This one is pretty straightforward. RM stands for remove. You just rm and then the name of the file, and it removes it. If you want to remove a directory, as you can see here, as rm-arrow, the arrow test is recursive. Whenever you see arrow in a command, it means recursive, which means that I'm removing a directory and whatever is coming underneath. So this is like a destructive. And then the F is just a force remover. So if you, let's say you tried remove and something was refusing to delete, what do? You force it out if you wanted to. And that's when you use the /F. So usually I use both of them together. I just use rm/rf or -rf. So that's recursive and force. And you take anything out, guys. This is a command I was warning you guys about before. And I'm going to go in there and do it real quick. So let's see, what files do I have here on my local? Oops. So I'm going to remove the DevOps that we have in there. So rm-rf, so remove recursive and force, and then DevOps. I know we created DevOps last time, but guys, feel free, you can use this for a file, you can use this for a directory, you can use this for anything. And if I hit this command, my DevOps is gone. Anything in between is gone. If there were 20,000 things in DevOps, it's gone, guys. So be careful when you use this command. But that's how you remove a directory that contains files and anything. So bam, you see, if I do ls, DevOps is gone, and I'm never going to see it again ever. You know, so that's how you delete files on a Linux operating system. So guys, you can practice. You don't have to practice. You can just follow along and practice later if you're having issues catching up, or if you have quick hands, you can quickly do it, and we move on. And the next command, guys, is to copy. So obviously, you want to be able to copy files from one place to another. So if I had DevOps, I want to be able to move DevOps from this current directory to the next one and just back and forth, right? So this is essentially the command, just CP, guys. Isn't Linux easy? CP, just copy CP source destination. So CP, if I wanted to move my file from /Linux to let's say Vitali directory, I just copy, I just put CP at the name of the file or the directory and then the name of the file, and then CP directory or Vitali, and it takes it straight there. So I'll show you guys real quick. I'll show everybody real quick how to copy files. So if you look in my folder, I have my cat right here, or I have ab.txt. So let me try moving ab.txt. So let me see my parent working directory, home admin user. So I want to move, you know what? I'll just create a, guys, do you remember how to create a directory? It's make D, right? Let me just bring back my DevOps. So make D DevOps, so I have my DevOps backup. So I want to move that file. If you wanted to create a dummy file, guys, just do a touch and then name of the file. You could create a file that you could use. If you wanted to create a directory, you could also move a directory if you wanted to. If you want to remove a directory, you could just do mkdir, name of the directory. It's going to make a directory and we can move them back and forth. So I'm going to move the a.txt that I just typed some few words into. I'm going to move them into the DevOps folder. So I'll copy a.txt, right? Remember, it's in my current directory. That's why I'm just putting the name of the file.
Now, wow.
And then I want to move it into DevOps.
Career picking for 9 months. Born now, people can't declare you don't born beautiful girl picking. You don't born nonsense. This way no balance. See my picking them.
William.
Mature woman then look what you do. That's why they work at the disgrace when I girls. I say people
where is that coming from, guys? Can you mute?
Celebrate their own born beautiful girl picking the nonsense and nonsense the born.
Where is that coming from?
Where's that coming from, guys? I'm sorry, but you're interrupting the class.
Coming from William, Tonya, or whoever that person is.
Yeah, just try to mute it, please.
Guys, we have to avoid interrupting the class, guys.
Yeah, man.
Wherever that is, I wouldn't tolerate guys just interrupting the class like that. Anyways, let's continue, guys. So anyway, I'm going to move this a.txt into my DevOps folder, guys. So copy the name of the file and then wherever you want to move it to. So if I press enter, automatically I'm going to see, since we're copying, guys, remember we're copying. So you're still going to have that file where it is, but you're just going to have a copy where you're moving it to. So if I put ls, I'll still have my a.txt is in there. But if I go into my DevOps folder, I should see a copy of that file in there. If everything went well. So guys, see? So I copy that file in there. So you can make multiple copies of a file. This is how easy it is to make copy. You can make 10,000 copies of this file. I could copy, and I could, so now that works. So to move it back to my previous directory, I'll still use copy. I'll use the name of the file. And guys, can someone tell me how to move it to my previous directory?
Things like PWD, CD, dot.
But yeah.
You don't need CD, but yeah, but you guys essentially know what's going on.
Yeah.
Right? So let's see. I already had a file in there. So let's see if you made two files, you made a copy of the file, or you just probably replaced it. But yeah, but that's essentially how you move. You copy a file. So I kind of want to do that with a different file that's not already present. So let me remove that file real quick. So we have that file gone. Okay, let's see, DevOps. Oh, I put double dots, two triple dots. Guys, you see the files back there? All I did was do copy the name of the file and then just two dots. Which two dots is saying take it to the previous directory, and guys, the file is right there. And you could do that to any file. If I wanted to copy from my home directory, look where I am. And if I wanted to copy that same file, right? Let me first of all delete this file right here so we can follow along really well. But if I wanted to copy that file and I don't want to go into DevOps, right? I just wanted to copy for where I am. So guys, this is how I'll do it. I'll put the name of the directory first, right? Yeah. And then I put the name of the file. You see? And then what am I doing now, guys? What am I using to bring it to this current directory? Remember, I told you that dot is the previous directory and dot is the current directory. Keep that in mind. The video will be there so you can practice. But if I hit dot, what I'm telling you is I want you to put in the current directory. So these are just small techniques, guys. You see the files right there. So that's how you copy to current directory. You know, the name of the directory. You can copy from any directory, guys. Any location where that directory is. If the directory is in /documents, /music, /anywhere, you can just copy from there and bring it to your current directory. You can copy from /music and move it to /pictures. Wherever, that's the power of Linux. You can move files from anywhere to anywhere at any time. That's why Linux is so powerful. So anyway, we got that covered. So the next command is going to be the next command will be going to be move, guys. So remember, guys, we copied. Now we're moving, and we all know the difference. Copying just copies that file, but when you move it, you move the entire file, so you don't have a copy when you're done. So if I was to move the a.txt into DevOps, I won't have it here anymore. It's going to be completely gone. So that's how you move files without making a copy of them. Guys, I hope I made that concept. Maybe I kind of confused you guys, but I hope the concept is clear. When you copy a file, the file is still there. You're just making a copy of it. When you move a file, you're moving the entire file. For example, let me try to move this a.txt into my DevOps folder. When it's done, we should not have that a.txt still present. In fact, guys, you can even move two files. Let me show you guys. I can move two files, not just one at once. In fact, I can move 20 files at once. While doing that, I'm going to also remove the ab.txt as well. You see that? That's how you move two files. You just basically name them. So I'm expecting that when I'm done, I shouldn't have any of those files present. So let's see. Guys, you see, the files are gone. So if I ls my DevOps folder, I should see those files in my DevOps folder, guys. I should see those files in my /DevOps. ls/DevOps. DevOps. Guys, you see the files in there? So that's essentially how you move files. So I can move them back just as easy. And this time I'm just going to use a small trick, which we're going to talk about later. But, you know, and I'm just going to use a small trick. I'm going to use a normal wildcard, and I'm going to move it to previous directory, you know. And it's supposed to remove all the files. You see, it's gone. I used the wildcard for AB. I guess what I would have done is using a wildcard for A, But anyway, yeah, we're going to talk about wildcard later. But yeah, it's one of those tricks where you can remove without typing the entire name. So we're going to talk about this later. It's going to be one of the, a little bit of the advanced skills that we're going to be using. But yeah, that's essentially moving. Moving is easy. You know, MV means move. Linux is very, very easy. You know, Linux is very, very easy. But you have to practice. If you go sit down, then you're gonna turn into rocket science. But if you practice, you see that's easy. So this one is, you know, just how you can create and extract files. Just keep this one in mind. With tar, you can tar files, and you can create them into what we call tar archives, right? So if I wanted to bundle a file and move them as an archive, I'm going to use tar. And you have different tar commands. So if you want to create a tar archive, use tar C and then the name of the file. If you wanted to extract the file, that's where you need the X. You want to display the contents, it's /T. Verbose. Verbose just means that I just want a whole bunch of notes or a whole bunch of information when everything's going on. So verbose means I want more information. So most of the commands we're doing right now, we're not getting any verbose. So we're not getting any details on how the process of how it's going on. But when you use verbose, verbose just gives you all the information. And then Z obviously is when you want to add a compression to it. So we're going to run that command. So I'm going to see if I could package my DevOps folder into a tarball. I need to make sure that I also have tar installed. My tar installed in my folder. So another thing you want to do, guys, is whenever I have doubt with the command, you know, I want you guys to get used to using help and man and all that stuff. Whenever you have issues with command, you know, you could easily just go on there. You see the exact same manuals. You know, you don't need my documentation and all that stuff. You know, Linux has everything you need. As you can see here, I just put help, and tar is able to give me all the different things that I can do with that. I want you guys to try using help on any command that you've been using so far. --help, just put the command --help, or just use man, the name of the command, and see what you get. And then you can just quit by hitting Q. That's a good practice.
Can you remind me real quick, if we're in a folder, how do we just go back to the main directory?
So if you went into one, let's say you went into one folder.
Yeah, I'm in my DevOps
CD
folder.
Yeah, cd ...
See, I tried that and it says command not found.
cd space ...
Oh, I keep forgetting to put the spaces.
Yeah, the space, you need the space. So was anybody able to get help? Oh yeah, oh, it's telling me right here that I'm missing the F. But anyway, guys, let's say I had a file that I wanted to create a tarball. You're not going to use a tarball a lot. I don't know why I added that in there, but it's just something to keep in mind. Usually use a zip and unzip, which is much easier. You just put zip the name of that file and it zips it for you. But yeah, but with the tar, you know, you can also create a tarball, which a lot of guys use, and which is the one that's more. So if I use zip, my DevOps folder, usually that zip should be able to zip that file for me and just create a zip of that folder. And zip will be able to, so I'm getting all these errors, so I'm just going to make sure that I have zip. My keyboard is so slow. Well, I don't want to convert. So guys, if you see, for example, it's telling me if I wanted to install anything, I have to be a root user. And to be a root user, I use sudo su, and then you put your admin user password, and you're going to be the root user, and you're going to be able to do any installation. But anyway, yeah, so those are the things that, you know, guys, like creating a tarball is kind of old school. If I were to use, I could use a zip real quick on my terminal, Mac terminal, and it's going to zip any file that I need. Anyway, this is another good command. that you need. For example, you were trying to troubleshoot and you wanted to see how much disk I have. You just type DU, and then it's going to tell you your disk usage. If you want it in human readable format, do DU/H. Now you're going to see your disk space and everything in human readable format. You see that, guy? Everybody see that? So it's telling me essentially what my disk is and how it's being used. So you can see some of them are using just 4 kilobytes, some of them are using 120. So when you're working with the real system, these are some very important information that you need. If you want to know which file is consuming the most space, you can run this even on your Mac terminal. If you had issues, DU/H in human readable, it's going to tell you exactly the disk space, what it's using. You're going to need this to troubleshoot certain things really. Keyboard is so slow. Guys, this is another thing I want to talk about. I know you guys saw me use this a little bit. I was just showing it in there just to prepare your mind. But wildcards are very, very good, very, very important. They're shortcuts, you can, I've used all kinds of wildcards and I've used them in different ways. I've used them as short forms, I've used them in script. So wildcard characters are like essentially characters like star, question mark, where you can use as pattern recognition, pretty much, pattern matching. Those are wildcards, and we're going to go over some of them and some of the most common ones as well, which is going to be the star, the little star. That's the one that I use a lot, and it helps, especially when you're trying to run through commands, you're trying to remove multiple commands, you're trying to copy multiple files. It helps when you can use wildcards. So the first wildcard we're going to use, which I just used, is this match right here. You see, this match can match anything. So for example, when you look here and you see the star.txt, what you're telling that command, you're telling it that I want anything that ends in .txt. So I don't care what's in the beginning. It could be, Linus, it could be Bajo, Zampa, it could be Ness, it could be anybody. But I just want everything that ends in .txt. This one tells me I want anything that starts with an A. This one says I want anything that starts with an A and then anything in between and then ends with .txt. So you can start to imagine what you can do with this command. So you can essentially say, all files in your machine or all music files that end with MP3, right? So you can essentially use this command and say, I want all files that end in MP3, end in -MP3, and you see all your music files without having to search through the entire system. I want every file that ends with PNG. So you want to see all your pictures. You want to see all your pictures without, breaking it back. I want all pictures. So this wildcard is very, very important. And you're going to use it for so many wildcards. Another one that I don't use a lot is the question mark. So the question mark only replaces one letter. The star replaces everything that matches, but the question mark is just for one. So I think a little practice will help for these two commands because they're very important. So let's say, let me ls so you can see. So I'm going to quickly create a few files. I'm going to create a few files real quick. So we have a few files. So to use the hashtag that we just had, the little star command, I wanted to search all files that ended in txt. We have quite 4 of them right now. So all I have to do is do this and say ls .txt, and guys, you see, it automatically matches anything before txt. So you can start to imagine how you can manipulate so many files because you're going to be working with a lot of files, a lot of documents. You want to be able to have shortcuts like this where you can easily pick up what you need.
So asterisk is like a search query that you put in your databases to narrow down text.
Well, yeah, in your Linux terminal.
In your terminal, sorry, to narrow down
search.
Or
to search particular patterns. For example, you can search anything. Okay, so I want to search anything that ends with an S, just an S. You see that? DevOps ends with an S. Documents end with an S. downloads, pictures, they're all NRS. So that's essentially this. So another one is I want to search everything that starts with an A and ends with a TXT. So let's see that. So A, my star in the middle is telling me that anything that starts with an A and ends with a TXT. I'm not even including the dot. It's automatically going to pick the dot as well. You see that? So that's one of the cool tricks. And then you can use this to search anything you can think of.
This is a long run, but do you know in iOS, like on your phone, if you go to your messages and you type one word, it pulls up everything. Is that the same command that's being used? Do you know?
One word? What do you mean by?
Like, let's say you go to your iPhone, for example, your messages. Let's say you type P, for example. Every text message that you've ever sent that starts with P pulls up. Is that?
Oh yeah, trust me, they're using the same algorithm.
That's the same.
It's the same algorithm they use in the backend. If I was the one writing that program, you know what we call that? We call that indexing. So what I'm saying is, what I'm saying is, whenever someone searches P, right, it's essentially running a command like this in the backend.
But this is what's happening.
So it's technically, in the code base, it's technically what it is. But if you're using Java, you're using Python, there's a different way we approach it, but it's the same idea pretty much.
Cool.
It's the same idea. It's not like asterisk running, but it's the same idea.
Same concept, yeah.
Yeah, so the question mark is just to represent one letter. So if you notice here, this question mark, what it's going to replace is going to replace the B and the F and the C. So if I wanted to replace two letters, I have two question marks. So as you can see, exactly what we said, the question mark just replaces one. So if I wanted to replace two letters, I will use two question marks. So question mark is kind of, it's a little bit opposite to the asterisk, because asterisk matches everything. But the question mark, the difference is only matches one word at a time. So one question mark is one word. You see that? So one question mark represents one word. So that's a big difference. But remember that command because you're going to use it a lot. If I wanted to move everything into the DevOps folder, right? Let me just show you an example of how it can be so easy to use that command. Let's say if I had a bunch of files in my system, a bunch of TXT files I wanted to move, and I don't want to keep typing move ab.txt, move ac.txt. I could just say, okay, asterisk, this is where I need your help, right? I want you to move every TXT file into my DevOps folder, everything that ends with the TXT, everything. So you see how easy this command makes things. So if I hit enter and I type ls, guys, you see all the TXT are gone. It moved everything for me. So that's the possibility of that command. It's so powerful. You see, everything is in my DevOps. It's so powerful that it makes your life easier. And when you start working with Linux, you see how important that command is. But yeah, keep that in mind, the asterisk. Asterisk will save you a lot of time and a lot of energy. Anyway, so this is something we have to talk about. We obviously have to talk about input and output types. So in Linux, when you run any command, like all the commands we've been running, if you don't get an error, right, in your standard input, if you don't get an error, right, it means that you had a 0, pretty much, right? It means that, I know Felix was saying something last class about zeros and ones. This is essentially what it is. So if I put in a command and it's successful, the command receives, the machine receives a 0, and then I receive what we call standard output of 0 as well. And then if you had an error, right, in your command, your machine is giving you is a standard output of 2. So how important this is now I can start redirecting my errors. So if I wanted to run ls to a folder that doesn't exist, if I didn't want the machine to tell me, oh, this folder doesn't exist, I can use a /2 to direct that output into a file, and I won't get that error anymore. So that's how you can start manipulating shell scripts and making sure that your users are not getting errors. And it's all about error handling, guys. So I mean, it's gonna make a lot. So this is some of the redirections that we use. I know I used this in the previous class. When you use this, you're redirecting to a file, and if there's anything in that file, guys, it's going to delete and then replace it whatever you're directing it to. If you use the 2 dashes, it appends. So it adds to the end of the file. And then this is to redirect input to a file. So before we go into that, let me do that real quick. So I'm just going to use the echo, and I'm going to type, how are you? let me just make sure we have a file in here. But do we have a file? Let me just touch the file real quick. Okay, so let me show you how the redirecting the input works. So let's say, let me just echo something. How are you? Oh, that's funny. My machine is so slow, guys. I don't know what's going on, but it types like it literally takes. So this is how are you? And I wanted to push this into a file. I wanted to redirect this output into a file. If I use this command, and then let's say I put A, the name of the file, it's going to go into that file redirectly. It's going to automatically spit that into a file. So let's try that. Okay, let's cut that file and see what happens. Let's cut the contents of that file and see what happens. Guys, do you see the word that I just echoed in there? I just redirected into that file, right? If I run the same command with the same append, it's going to automatically delete the old one and put a new one. If I use just one, so I'll do that real quick. It's easier to do it by practicing. So I want to make it really apparent. So I'm going to change this into caps so you see the change. So keep that in mind. So I want to do the same command, echo. If I cut that same file, you notice that you replace the old word and replace it with a new one. Okay, sometimes you want this, sometimes you don't. If I wanted to add it to the back of this file, now I'll use 2. So I wanted to add this on the back of this file. So instead of replacing it, I want to append. Guys, I hope you know what append means and to add at the end of it. So if I want to append, I'm using 2 dots. And guess what? If I cut that same file, I should see both words in there. It shouldn't be replacing it. It should be adding it to it. You see now? So those are just some little tricks in Linux. You can redirect anything, guys. I could say ls. You could redirect. It's so important, and I keep emphasizing it's so important these commands because you could do. I'll just do a few examples so you can start seeing how important it is. So ls normally this is what ls will give us, right, guys? Right, everybody. This is what ls will give us. But I could redirect this into a file. I could say ls, and what's our command? What I'm telling the machine is, whatever answer you get, I want you to, instead of displaying to me, I want you to also send it to that file, right? So now it's not displaying anything to me. So you can start to see how you can redirect output out and everything in Linux. So if I cut that same file right now, my ls command should be in there. You see that? Isn't that so cool? All the contents of my ls command is now in that file. And you can do this for any command in Linux, anything, any command, man, copy, you could send the output. So let me just say cat, let me just try something that doesn't exist. What's Linux telling me? It's telling me that SBT, no such file exists, but I don't want to hear this from Linux. Linux is a problem. So I want to tell Linux that if this file doesn't exist, instead of telling me, I want you to save that error to a file so I can come later and check it out. This is how you start to diagnose problems, guys. This is how you start to make sure that if my script is running, I have a report for it. So now I want to tell you if there's a problem with a certain command, a certain execution. I want you to store that. Instead of telling me that this doesn't exist, I might not even be there. I want you to store that to a file. So that's when you use your standard output. You use your -2. And I hope I got that command right. And guys, keep in mind that most of these things I'm doing out of the top of my head. You know, I don't prepare for these classes, you know, because these things that I do, and I know it too. Every now and then we're gonna have some hiccup, but you know, I should be able to sort this out. But anyway, /2, you're telling the machine that if there's an error, I want you to output that to a file. I want you to, you see, guys, we didn't get any error, did we? So you can start to bypass all the errors in Linux by doing this simple trick. And you can use that in a script. You can tell a script, if you have an error, I want you to store that error in a file. I want you to continue going. So when I come back later, I can see all the errors that we had. So now, instead of it telling me, oh, no such file exists, now, because I use /2, and remember, keep in mind, class, keep in mind that /2 here means standard error, ST there. So the machine already knows that this guy doesn't want to record, this guy doesn't want the error to be on the screen. He wants to record the error. So I use this /2 to tell the machine, put the error in this file. And And then it automatically does that without telling anybody that no such file exists. So if I cut that same file, that ab.txt, I should be able to see all my errors in there. And you see that? So now my error is in the file. So this is how you can start running scripts and then logging your error to a file. And you can come later. You can even stream this live and be able to see every error that goes on. So when you hear about machines and you hear about errors going on and you hear about monitoring and all this stuff, this is essentially what is happening. They're recording all those errors in the file and then they're streaming it live. And you can see them in all these monitoring platforms that you see. This is the same idea. We're having this error, could be any error. It's still going to be /2. That's the same error you're going to use to forward that into a file. And the possibilities are endless. With this same command, now I can be able to tell my Linux what to do with error. I can say, okay, Linux, if we cut the file and if the output has, now let me get you guys, let me get everybody thinking. Let's say I wanted to do something with this script, or I wanted to use an error. I wanted to say, if a certain file, there's a lack of a certain file, I want you to create it. You can use the same output and use your /* or something we're going to look at called grep, where you can go into that error and then you can have Linux go into that error and be able to look and read and say, oh, there's a file here, there's a no such file exists. Let me create that file for you, just by reading your error logs. So there's so many things we can do with this, but just keep that in mind. Every error that you see is not always an error. You can redirect that into a file. You can read it. And then I want to hear if someone's been keeping up. Let's say I wanted to redirect my success. Which command will I use? Which number will I use?
That's 0.
0 is what the machine you give to the machine when the machine receives when you get a success, but it's going to be 1. So using 1, you can redirect not just your failures, but you can also redirect your success. You're going to see something like this many times. You're going to see like a 2 for 1, where someone is directing. I'm running a command like cat sb.txt, and I'm using 2, and I'm directing my error to a file called, you see something like this. Oh, where is it? My machine is so slow that I go ahead and type. You can use 2 to direct to an output, to an error file, error.txt. And then at the same time, you're using 1 to direct to another file, let's say success.txt. So when you use this command, essentially you're telling the machine that if this command fails, I want you to log that error here. But if it succeeds, I want you to record my success here in success.txt. So it's like a double-edged sword, guys. So this is how you start to control, you separate the losers from the winners. This is how I start to separate and say, okay, I don't want errors and success to go to one place. I want my errors to go here. So when I come back, I can be able to go to error.txt and say, okay, these are errors I had. I'm going to succeed and say, okay, this is the things that succeeded. So just keep your mind thinking. That's Linux. Anyways, we're going to proceed.
I have a quick question. When you say you record errors and you repeat the process, that's something you will be doing in software development, right? Not in the Linux platform.
Well, recording errors is just going to be part of your day-to-day troubleshooting.
No. I'm talking about earlier when you said if you do the process, you can just make the process repeat itself. That way you don't have to go and do it at a time. The system can do it for you and go and actually fix the errors.
Yeah, you can do that. Linux, you do that with Linux. We'll talk about something that does that in a minute. So anyway, this is another cool command. So with this command, you can see the difference between 2 files. So let's say today, I had a few files on the system. That command anyway worked. So if there was a failure, it would be an SB bit. Let's say I have a few files and let's say my daughter came in here and did some changes to one of my files. And I want to see what the difference is. It's as easy as just using diff. Let's say I have ab.txt and a.txt and error.txt. I want to see the difference between the 2 files. So I'm going to put error.txt on one end, and I'm going to put a.txt on one end, and this command will be able to tell you the difference between both files. You see that? So both files are completely different. So that's why you see this double dash here. This double dash here is telling us that this total files, the other file, this is the content, and it's completely different from the other file. That's why there's no interlap. There's no interlap. So you can use that command to differentiate any file. So the idea is just to understand that if I had two files and I wanted to compare, see the difference between both files, the similarities and the differences, I'll use div. And div comes with many commands. With div, you can also say, okay, I just want to see the differences. Sometimes with div, you say, I just want to see the similarities. You know, you can do all that. And how you know all that is by going to div /help or man, or the manual, or manual of div. And you'll be able to see all the different options. So just keep in mind that it's not just about using the commands, there's always going to be options that you can use to differentiate your file. So this is important, just keep that in mind. This is another cool one, grep. So this one, I use this a lot, and a lot of engineers will use this a lot. So grep is like exactly what it is. It's a pattern searching, you know, so I can go into a file and search anything I want to search in that file. It's going to exactly tell me what that thing is and what line it is. So you can have 10,000 lines of code, and I can use grep to go in that code and search liners. If there's liners in there, it's going to tell me. If there's an alpha in there, it's going to tell me. If there's a beta in there, it's going to tell me. So that's the power of grep. So I use this a lot when I want to go through big files. I want to look for patterns. And then you can see we have our -i, which is what I use a lot because it just ignores the case. So if there was something called liners in lowercase and liners in uppercase, or if there was just liners in uppercase, I don't care for that. I just want to see there's a liners, upper or lowercase, you use -i. And then C is a count. So I use -i a lot, and we're going to do a quick symbol. And then before we do that, I want us to talk about pipe a little bit, because whatever you do with grep, you know, it's always nice to pipe it in. And pipe is essentially a combination of two commands. So I could use pipe to command two things. So when I say pipe, it's essentially, it sounds exactly what it is. You're piping something, you put something in a pipe, so another command can use it, essentially. So anyway, so you know, it's always easier when I do a little practice with it. So we have our few files here. I know what is in most of these files. For example, the last one we just did was the a.txt. I know there's a few things in the a.txt, and I know downloads is one of them, right? So I want to just search that file to see we have downloads in that file, or anything that starts with no, that's, well, I mean, it's downloads. I want to see if there's a downloads in that file. And then I want to see there's downloads in that file. So what's the name of that file? A.txt. Guys, do you see that? Automatically it pulls it out. It tells me there's a download in there, and it brings that line. So what grep does is it brings the entire line. But unfortunately for this file, that line only has download. Let's say that line had something like download a text, download a workgroup. It's going to bring the entire download the workgroup to the screen. So you can imagine the power you can use with grep. This can search any file, 10,000, 20,000 lines, 100,000 lines of file. Grep will go in there and pick up anything you need to pick up. So this is a very important command, and I use this command every time that I work. So let me do something a little different. What was the name of that file? A.txt. I just want to see the content. Okay, so I want to cut the line that has how in there. So I want to see if, so I'm essentially telling grep, can you search that file to see if you can find how in there? If there's how, oops, oh man, this thing. If there's I in that file, I want you to search for it. I want you to bring it to the screen. Search that file to tell me if there's a how in there. I want to know if I have how in that file. You know, you see, grep picks up all the two hows. It picks this line with the first how, and it picks up this line with the second how. And it shows it to the screen. So if I had 10,000 lines, grep will pick up anything. So you don't have to use the I, guys. I is just making sure that, you know, it's ignoring the case. So even if it's uppercase, it's lowercase, it doesn't care. It's bringing everything that has how, bring a how. So it helps. But you can just use grep. The name is so easy. Grep what you're looking for and the name of the file you want to search. That's it. and it picks up anything. And then let me show you where pipe comes in. So when you're using pipe in Linux, you're essentially telling Linux that whatever I'm doing, I want you to send this into another file. So if I said ls, if I ls and I want to send this ls output, what you see on the screen, if I want to send that to another file, that's when I use my pipe. So think of pipe as pipe. You're piping it to another program. You're piping it to another command. You're piping it to another, whatever it is. So I can, for example, let me do an example. I could pipe this into a sort command. Oh, sort, not dot. So what I'm telling the Linux is, this Linux is just annoying, man. I can't wait to start using the cloud. What I'm telling this command is, whatever you search in ls, I want you to sort it, right? I want you to send that output so sort can sort it out, for me. So you see, I piped that input. Instead of it just displaying it to the screen, it actually sorted it out for me, because it sent it to sort, and sort did its job, and then it sent that output. And guys, you can keep piping and piping. So you can literally keep piping and piping. So I could ls, I can sort it out, and then when I'm done sorting it out, I could actually send the input to a file. But another thing that you could do with grep is, if I cut my file, let's say a.txt, I could pipe that, and I could send that into an input. For example, I could pipe that into grep now and say grep. I know there's contents in there. I'm displaying the output to you. I want you to search that output, and I want you to look for a file called how. And grep will be able to do that for you. grep-i, and then with that output, I want you to look for if there's a how in there, in that output I'm piping it to you. And that's one of the commands of pipe. And you see, pipe was able to receive the output and then search it, and then find how, and then display it to the screen. This is one of the ones I use the most, to pipe it and then search it to grep, pipe it to a file and then search, and all that. So you can use that. You could let's try piping and see if we could pipe, sort it out, and then whatever we've sorted out, we could store in a separate file. Let's see, sort. Anyway, this is another good command, and a lot of you are going to find this very handy. It's an alias. I know there's so many of these commands that we use that we just get tired of using them. I do that a lot. For Kubernetes, I have so many aliases on my machine, just because I'm tired of typing the whole thing. I just want a short form. For example, ls-la, I just want it to be L. You can put that in an alias. And everything. This is another cool command. I'm sure some of you are going to find it really fun. We're gonna do that real quick. So let's see an example. Let's say I was a guy that instead of typing grep, I keep typing grpe. I'm like, okay, this is just something that I can't fix in my head. Like, I'm just going to create an alias for it. And this is simple. This is it. This is how easy it is. It just automatically creates it for you. So let me do a quick example. Let's just say we just did cat a.txt. And it displays the output of a file, but I don't want to run cat.a.txt because I've been doing it a lot. Every time I come, I have to write cat.a.txt. Every time I come, I have to write cat.a.txt. So now I'm like, okay, all right, enough suffering, and guys, follow the syntax. Is right here, alias space. What you wanna alias, and then the alias you want to use it for. It's essentially what you use grep, you put it for grp. So what I'm going to do is I'm just going to call this C. From now on, I want my alias for whatever it is for cat to be C. So I'll say C equal, and then I'll put whatever command that is. This machine is starting to type by itself. So, okay, so I want my cat.txt, this is what I want to put in an alias. So each time I come, instead of typing cat.txt, all I'm doing is I'm just typing C and it's automatically running that command for me, right? That's how you put in an alias. So you can do this with multiple commands on your machine, and it saves you so much time. So if I come back and I say, okay, I want to run cat.txt, guys, you see that? Just by typing C, you automatically, just by typing C, it automatically runs that command for me. I know we type a lot of ls as la as well, which is going to list everything in long format. Let's say I don't want to have to type that. I just want that each time I want to list everything in long format, I just want it to be LL instead of ls-la. I create my alias for it, right? And I save it in my machine. So each time I type LL, it automatically does a search for me. So you know, so you can start to see the possibilities. There's command that I run, like kubectl this, kubectl that for Kubernetes. I just put a K. So for kubectl, I'm putting K for my alias. So each time I type K, he already knows I want kubectl. You can do this for anything, any command in Linux. And now you can start creating your short forms and creating your lazy engineer. Because I'm a lazy engineer, guys.
And do you question, please?
Yeah.
Do you have a file where you store all of those shortcuts? And then
well, you have, but once you have your commands, right? It's going to be stored in your machine. But yeah, I have a file that I have some commands. I put in my alias. I actually have them in the GitHub repo, I think.
Then the second part
is it's mostly Kubernetes alias. I don't have a lot of Linux aliases, but I have a lot of Kubernetes that I run on Linux that I have the aliases because I run those a lot on a daily basis. So yeah, keep that in mind.
So what if you create two commands with the same C, for example, with the system prompt you saying, hey, C already exists as a command? If you're creating a shortcut and, for example, you use two, you already have one that starts with C and you're trying to create the same thing like a duplicate, does the system prompt you?
I think it's going to just replace it. It's going to replace that alias with new alias.
Oh.
Yeah, automatically replaces your old alias. And this is always going to be what we call, it's going to be persistent with your current shell, right? But then if you delete, if let's say you close your terminal, all your alias is going to disappear. So the best way, if you want it to stick across everything, anyway, let me go back to this command just so people are clear. Just what we missed in this command. Okay, this is not a command. Let's see. What's the pipe? This one. So if I wanted to sort something and then store it in a file, oh man, this is not time to. Anyway, if you wanted to store something and store in a file, you won't have to pipe it in again. I think that's where the error was. You can just sort it and then automatically just send it to a file, pretty much. So hopefully this is supposed to work. So keep that in mind. If you're gonna do something, you see, automatically it sorts it and it stores in the file. So I didn't need that extra pipe to do it. So I just made my life difficult. So the last command that you want to save in a file, you just pipe it in there straight. I mean, you just redirect it without using another pipe. So anyways, yeah, just wanted to clear that one out. Let's see. So aliases, is everyone okay with the aliases? Is everyone okay with everything so far? I'm looking at the questions right now. And believe me, the videos by tomorrow evening, the videos are going to be uploaded. And you can go to the same link, or you can ask me and I'll send you a link and you can go through the videos. Any questions? I like the pace. We're picking up pace much faster than the last time. So remember, it's not that hard, but you just have to practice. Go and practice and everything will make a lot of sense. So I don't see any question in the chat, so I'm happy everybody's understanding. And this is one point I wanted to drive home. Every machine has something you call the .bash profile. So whenever you do an alias or any other change for that matter, it's going to stay, you're going to be persistent for that shell. When you close that shell, you have to redo it again. But if you want it to be persistent, like every time I come in, it's going to be there. You have to edit something we call the .bash profile. Let me see if I can quickly go into my .bash here. Hopefully this thing has a .bash. Let me catch it real quick. Your .bash profile should be on your home directory. So we are in, I think we're in, all of us, check your PWG, you should be in a main user. Yeah, and in fact, that ls-la, the idea will be that you see something called .bash profile in there. You see it, guys? On your machine type ls-la, you should see one of the hidden files called .bash profile. That is very important, a profile, because that's what sets your default anything you're doing. So if you do, this is the .bash profile. Make sure you're in a home directory. Make sure you're in home admin user. If you're not, all you have to do is cd into home. If you're not there, you just cd into home admin user and you should be there. If you're not there, just cd into home admin user and it should take you there. And there you should have your .bash profile. And now to open that profile, remember we used our VI. For me to open that profile, I'll just use my VI. .bash_profile. There it is. Use your VI editor, open it, and you can see the file. This file is very important, so you want to be careful with it. And for me to start typing, what do we have? I just type my insert I, and it's going to let me to start typing. So if you wanted to keep your aliases across all your reboots, this is where you put it. You put your hashtag, which stands for comment. You say, okay, I want to store my aliases right here. And then you just put the same command, alias. I want my LL to be ls-a, and then ls-a. And that's the same command we run on to have our alias. Once you store that command there, it's going to be persistent. It means that even if I turn off my machine, I come back, that alias will still be there. So this is how you keep it forever, pretty much, as long as you're using that machine. You just store it in there. You can store multiple commands in there. You can store multiple things in your .bash profile. So keep in mind, your .bash profile is a very important profile. You see, it says here, user-specific environment and startup programs, environmental variables, aliases, and anything you can think of. And then when you're done, you hit escape, colon, as usual, and then WQ, and then exclamation. This takes some getting used to. It took me a while to figure it, to master this. So keep that in mind. You have to practice, keep using it, and then you master it. So now my and it's always going to show me that alias. Linux is so nice, class, so nice. I love Linux. There's nothing you're going to do in IT without Linux. So this is the foundation, just so you can be able to know how to move around at the moment. So we covered aliases will help you. And this is another fact, it's called environmental variables. So environmental variables is exactly like you see, it changes the way programs behave. It's just a bunch of key value pairs. I'll repeat that, it's a bunch of key value pairs. So on my Linux machine, if I open my .bash profile and put editor equals nano, whenever a file is open, it's going to automatically be open in nano instead of the Vim editor. So automatically you're changing the way your Linux behaves. So environmental variables, you can use them anywhere. You can just use them on a profile, on a regular machine. You can use them, and then to see the contents of environmental variables, you can just echo the contents pretty much. And then you have your file. So let me just show a quick environmental variable, see if we can create a quick environmental variable. Let's just see. While I'm doing this, I just want to ask again, is everybody following along? Is everything okay?
I signed in late, so I'm just going to watch the video tomorrow. Yeah, I have to leave right now, but I will also watch the video.
Yeah, before you leave, I just want to, just take this time to say that, we might be ready for a break as well. So I'll just take this time to add a break. But I just have one or two things to say. One thing is, we have to create something called office hours because some people are calling me at 5 a.m. in the morning. Yeah, people are literally calling me 5 a.m. in the morning. So we're gonna establish some hours that you can call just so I'm ready and you're ready and I'll pick up your call. So I'll say 2 hours before class every day you can call me. So our class is my time 6 to 8, but it could be different in other time zones, which is like 8 to 10 in the East Coast. So 2 hours before that, so 4 to 6, any time of the week, any day of the week, you can call me within that time and I'll be in front of the machine. And that's perfect because I'll either be just signing off work or I'll be at work. So I'll be in front of a laptop. So any of that time, any 2 hours before that class time, any day, Monday, Tuesday to Sunday, you can contact me if you have a question. So remember, guys, 2 hours before class, I'm available any day. You can contact me if you have questions. Please, guys, don't be calling me 5 a.m. in the morning, please. I have a family and some kids. Yeah,
so are we changing the time on Saturday, or it is still the same?
So far it's the same. If you're late, you can just watch the videos. Like I said, the videos I'll be uploading them fast. Now I worked on my video editing skills, so I should be editing and having them really quick.
Can you also upload this PDF file
look, when you go to that video and you look on the description, you're always going to see this file.
Okay. All right. Thank you.
Yeah, and then one more thing. Guys, this is 2 weeks into the class, and I know some people still, I'm not calling names, but some people haven't paid. You know yourself. So make sure you contact me. Each student has to, by the end of this week, by starting next Tuesday, you need to have given at least $500 before. Otherwise, because next week I'll be sharing a new Zoom link, and anybody that hasn't given at least $500, I'm not going to add you in that Zoom link because. For me, think about it. It's easier for me to work with smaller numbers than bigger numbers. And it's easier for me to focus. And if you're not paying, it tells me that you're not committed at all. And see all we're doing now, we're just barely scratching the surface. There's going to be, a lot of things that we're going to learn. And if you're not committed to pay, I don't think you're going to make it all the way. That's the first red flag.
Do you have Venmo or Cash App?
Yeah, I do. Yeah, I have all of that. So.
Okay.
Make sure to reach out to me. I know, this is pay week, so this is perfect timing. So yeah, those are the two things I had to say. So we're gonna go for a 10 minutes break and then we're gonna come back and see what we can do for the end of class.
All right, I'm out.
All right. Okay, guys.
I see you have a card.
Oh God, not again. Who is that? Who is that? Is everyone here?
I'm here.
Cool.
Yeah, I'm here.
So, all right, we'll proceed. So, we were talking about environmental variables. I can't emphasize to you how important this is, but as we start to do more DevOps, you see how important environmental variables are. But keep in mind that this is what you would use a lot when we're using Docker, Kubernetes, and all that. Actually, today, one of my projects at work, I was creating environmental variables from what we call config maps in Kubernetes. So they're so important that it changes, like I said, it changes the way most programs behave, how your Linux shell behaves. If you want to understand more about what I mean, I want you to run this command on your Linux box. I need to clear. Run this command on your Linux box, print, I hope I got this one right. Print env. Oh yeah, there it is. Run this command on your terminal and you see that most of the default behavior of your Linux system has already been pre-programmed with this command. For example, let me stop right here. For example, the language, we already use environmental variables to say, okay, this machine is going to be using the US UTF-8. What I'm teaching you, when I did Linux class, no one taught me these environmental variables, especially to this level, because back then they didn't understand the power of it. But now that we're getting to DevOps and all this stuff where, Docker images and Kubernetes, it's really bringing the power of environmental variables. Now I have to make you aware of what environmental variables are and how you can use them. So for example, you see language, ENA, I'm automatically telling my system that I want the language of this system to be in English, and it has to be UTF-8. If you came and you wanted to, if you put this in your .bash profile, lang equals something else, and you reboot your machine, it's going to automatically change your machine language. So you could literally change lang equals something Spanish right here, SPE or whatever the code is, and then you reboot your machine. This environmental variable is going to change your entire machine to Spanish. So you can start to see the power of environmental variables. It's amazing, class, what you can do. Let me go down and let me look. Okay, see. I saw another one that says PWT. Okay, you see PWT? This is how your machine knows what your current directory is most of the time. So if you echo this command, if you echo $PWT, it's going to tell you where your home directory is. You start to see some of these things make a lot of sense. This is important. You see home? There's a variable here for home that tells the machine that your home directory is home admin user, and this has been our home directory. Keep in mind, environmental variables, they're so important, they're so powerful. You can do so many things with this environment. You see my shell? This is another one. I'm telling my machine, I hope you have this command open so you can follow along. Shell bin bash. So I'm telling my machine that I want my default shell to be bin bash, and that's what we've been working with, bin bash. If you were to change this to Z, if you run the same command in your Mac terminal, your command is not going to be, the shell is not going to be bin bash. You can run print env on your Mac, and it's going to be a Z shell. You're going to see Z here, as opposed to, in fact, let me see if I could verify that real quick. So this is the same command I'm running on my shell, and yeah, it's saying bin bash. But bin bash is just, like I said, I told you all before Linux, Mac terminal is still in the Linux operating system. So everything you see that is telling you, oh, my shell is a Z shell, is a bash shell in the back end. So now, from this environmental variable, we're able to see that we're using a bash shell, but it's telling us that we're using a Z shell. So they're basically stealing but it's copyright, Linux is open source, so anybody can take it and do whatever they want. So that's essentially what Apple is doing. But you could come here and change this to Z, to /Z, and each time you log in, it's going to be a Z shell that you have. So just keep that in mind. Good to be able to verify that. But I promise some people that have a Z shell, looks like I have the bash shell. But some people that are using Z, if they run it, they might see a Z shell. Anyway, let's keep going down. We have pad. Pad is where you put the executables. We're going to talk a little bit about this. So we're going to use this. And these are all inbuilt commands. So to see where the command is, usually, I've been using echo, and I'm sure people, a few class has been wondering what the echo does. So I can use echo to see the value of my environmental variable. So if I use echo and I put that PWT that we just saw on the top, echo should be able to tell me the value. You see, it's telling me that it's admin user. That's another power of echo. If I say echo, tell me what my $shell is, or what the environmental variable shell contains. Well, that has to be lowercase. I say echo, tell me what the shell environmental variable has. Echo tell me that, okay, your default shell is bin bash. So echo is a guy that snitches. Echo can tell you any environmental variable what it contains. Like home, genome, any of these variables you see here, and you can create your own. You can create normal variables, like I could say Linus equals to, let's see, Linus equals to talkative. And then I save that variable in my machine, right? And I save this variable in my machine. And I say echo, tell me what Linus is. I want to know what Linus is. And I type echo, tell me, would that always remember the dollar sign. Always echo, tell me what Linus is. You see, echo told me Linus is a talkative. So pretty much that's how you can store your own variables. And then to make them environmental variables, remember, this variable I'm storing is just for my command line to use. Just like you would use a regular alias. It's just like a command. But if I wanted to store it as an environmental variable, I would use this command called export. So I'll tell Linux, I want you to export Linus as a talkative. I want you to export this. So I want you to turn this into an environmental variable. And once I do that, and I say export, automatically Linus is an environmental variable. So now when I echo Linus, I will get the same thing. But when I type print env, I should be able to look and say, okay, what I'm expecting is Linus should be in here somewhere. Oh, there we are. You see? There is Linus. So there we go. Linus is your environmental variable. So it's already stored in the system. So this is how you can change your environmental variable. This is how I can temporarily change my shell. You know, I can temporarily change my shell to something else, and it automatically stores in the machine. You see, Linus is here because I exported it. So keep that in mind. We're going to work with environmental variables when we're working with Docker, but you just to keep that in mind to see how you can start manipulating these things. And guys, remember, practice, practice, practice. Go watch this video. It's on YouTube, so you can even put it on fast, 2x speed, and you'll go faster. Or you can skip. A 2-hour video on YouTube, you can watch it in 1 hour. And if you just watch certain parts, you can just skip and practice, skip and practice, and it's that easy. So that's environmental variables. You know, that's a good. Keep that in mind. You know, most classes will not teach you that, but I'm teaching you that because it's important, and we're going to be using that a lot. So that's just how you manipulate environmental variables. So it's an important concept, very important. This is another one. So this is just, you want to see the processes running in your machine. So if you run ps-ef, you should see the processes are currently running in your machine. You see, this is important for troubleshooting. You know, if your machine is all acting up and I want to go quick and see what's running in that machine, you just run ps-ef and you see what's running on that machine. You see, you can see the root, the pit 1. You know, we'll be running the system D. If I display the program, every program is running in the background. You can see here. This is a cool diagnosis tool. You see, I can see every program running in this machine, everything. You know, whatever user is running. Some of them are root, which is me. You know, some of this program you don't even know about. You see, this is another command running. We just ran this command. You see here, class? That's the command we just ran. This is it right here. So it's picking up everything that's running. So nothing can hide in Linux. You can find anything in Linux. Another cool command that you want to keep in mind is if you want to see CPU and all that stuff in your machine, there's a cool command called top. And top is going to tell you CPU percentage. You can see here. Oh, my machine, these are all cool. These are my little tricks in Linux. That I'm teaching you everything that I know and everything that I use on a daily basis. And you can watch the video. You can write it down somewhere. But these are things that you can say in an interview and they'll know that this guy knows how to use Linux and he knows how to troubleshoot. So I can see my CPU right here. If a machine was using a lot of CPU, you run your top, you're able to see that this guy is using the most CPU, and it's not a lot, it's just 1.3% of my CPU and stuff like that. And then this guy is using the second most. You can see all those commands that are consuming stuff on your machine. That's the Q. And you can just hit Q to quit. And then another beautiful one is HTOP. I don't know if we have it. If you want to have it, a fancy one, you could try. HTOP is not available. You have to install it. But HTOP is the same thing, but it comes in color format. It's more beautiful than what you have here. So that's another cool command to see what's using CPU, what's consuming my machine. And then you can queue pretty much. Like, for example, I know we ran the ps-ef, and we were able to see some commands that were, running. If I wanted to stop any of these programs right away, this is all I need. I need to come here and run my ps-ef, and then I'm looking for this number here, the pit number. Once you have that PID number, if I wanted to kill that number, you don't want to run, you want to kill the PID one, because PID one is always the most important. It's a system D, as you can see here. If you keep PID as 9, you can shut off the system. So PID one is always the most priority in your machine. So you don't want to worry about PID one, but you're going to see other things like migration number 11. And usually if you want to stop that program right away, it's very easy. You can just run Q -9, and then you put the PID number, and then it's going to automatically kill that program right away, guys. So that's just another cool trick. Linux is really nice. So remember, this PS.ef display all processes full. You can display the process tree, and there's so many things, but this PS.ef, that's the one you want to keep in mind. So the thing about Linux is when you have a command, just pick one that does everything you need. For PS, the EF does everything you need. So you just keep that in mind, and whenever you want to run and write this thing somewhere. And you see that queue we just talked about? This is how you queue processes. I didn't even know how to slide for it. But anyway, this is how you queue the processes. Control C, I know we talked about this the last time. I know Boris was asking me about Control C. It queues the foreground process, and then Q sends the Q the PID number, the PID I just showed you. There was 1, there was 2, there was 11. Q the PID number, and it queues that program right away, like on the spot. So that's how you terminate programs that are hanging, programs that are causing issues. That's the Q-9 that I told you. So like I always say, I'll tell you my tricks. With these commands, you just look for the one that works, does the most. For me, the most destructive is Q-9. That's why that was the first thing that came to my mind, and that was the first thing I put on the terminal. And this is it right here, Q-9, and then the PID number, and it will destroy that program right away. It forces it, it destroys it. Some of this might fail, but Q-9 will not fail. So remember, with Linux, just keep your little tricks in there. And then this is another good concept that I want to talk about. It's called cron. So cron is like a time-based scheduling system. I know Boris was asking me that, how can you put a program and just let it do its thing, right? This is the guy that does that job. It's called cron. And then the program that does it is called cron tab. So I could put my machine and say at 1 a.m. in the morning every single day, I want you to cut this program and put the output in this file. Cron is the guy that does it. Now you're starting to get into the real Linux. It's like a scheduling system. I'm saying this machine, do this at this certain time, do this at this certain day. And we're going to look at the format of cron. We're doing some really cool stuff today. So let me go. So this is essentially the cron tab format. This is not rocket science, so don't be scared. This is really easy. So with cron, you have three of these stars, 1, 2, 3, 4, 5 of them, and then your command. So as you can see, I try to make sure these slides, I take these slides from professionals, so I could try to really explain some of these slides. Most of these slides I didn't create them, but I look for the good slides to help us understand. So the first star you see here tells us this is a minute. So any minute from 0 to 59 minutes, right? The second star, as you can see, is the hour. The third star is the day of the month. The fourth star is very easy, month of the year. And the last one is the day of the week. So this is how you can start to schedule programs, schedule applications, and things like that. It's fun, So anyways, we're gonna go and see some examples. So the slide will be there. Remember to go and look at this slide again. But the first is always going to be the minute. So if I wanted something to run every 2 minutes, I'll just put my 2 here and leave every star open, everything star. And that thing's going to run every 2 minutes. That can be destructive, be careful. But yeah, your program will be running every 2 minutes, So that's how you run. So see, for example, this is an example. I want this program. This is how you let something run every Monday at 7 in the morning. So remember, our minute is going to be 0 because we're running exactly 7, not 7 minutes, 10 seconds, minutes, or 7:20 or 7:10 or 7:05. It's exactly at 7. So we don't need a minute. So our minute is 0. And then our hour is at 7. Remember, this is 24-hour clock. So 7 is going to be our 7 in the morning. This is like French time, And then our star was saying that, every day of the month, another star, every month of the year. And then we have 1 year, that tells us, the day of the week is right here, guys. And so remember, let's go back to that slide. So we have, the day of the week, which is 0 to 6. We have the month, Oops, what's this thinking going back? We have the month, day of the week, month, day of the month, hour, and minute. This is going to always stay the same. So if you can take a picture, take a screenshot, go online and take this and just put it in your phone, this tabs is always going to stay the same. So this is it we're doing again. We want it to run once, every Monday. So Monday is 1, Tuesday is 2, Wednesday is 3. So this is how you can run your weekly report. You see, this was a weekly report. So I can say every 7 o'clock, every Monday, I want you to run this report and send it to this guy. We'll send it to our accounting team. We'll send it to our, this is how you set it up in Chrome. And then it's going to run every, weekly, And I have so many examples, that I was able to find online. This is the example you want it to run every 15 minutes. So you don't have to master it. You just have to find the pattern. If you go online, I promise you, if you, whatever time frame you're looking, if you're looking for, I'm looking for something that's going to run every 30 minutes. You just Google online, you find someone that already written that for you. You just copy it and put it in your cron tab. So remember, you're not reinventing the wheel. Everything is out there. You just need to know, the main key of this class is know what you're looking for. Because if you don't know what you're looking for, how are you going to find it? So if now you already know about cron tab, and you know, okay, there's a program that I can use to run my things every single minute. Okay, now I'm looking for something that's going to run every day. Now you go online and say cron tab to run every day. There's even simulations online, because these are things that people don't want to be learning. So everything's online. You just copy it, you run in your cron tab, and you're good to go, man. You don't have to. It's not rocket science. Everything is online. Remember, almost everything is online, but you have to know what you're looking for to be able to find it. So that's why I'm here. I'm teaching you. And if you don't understand, you can always find that information. So this is a pretty cool feature. I used to use this a lot as a database administrator. And even as a system administrator, the thing is when we start doing DevOps, we're going to see that we can use Jenkins to do the same things that Cron is doing. So Jenkins will do that for you and stuff like that. But when you have this in mind, it really helps because you can still use this and you can prepare you for the future, what we're learning. So keep that in mind.
You just muted yourself.
Oh, my bad. So yeah, so we're gonna run some cron, and let me make sure there's no other slide here that talks about cron. So this is another easy one. I have so many shortcuts. So this is for yearly, annually, monthly, weekly, midnight, hourly. This is a cron. So everything's online. Everything's easy. you just copy it. You copy as 000, put your command and set up your cron time. You're good to go. You don't need to be memorizing any dates. But it's good to understand it, but you don't have to. Everything is online. I even have the annually, monthly, and this is how this is going to show us, how you can create your cron job. So I'm going to go ahead. I'm going to go ahead and I'm going to run cron tab, and I'm going to create one cron from a file, and then we're going to see if it's going to run. So let me look for the one that says 5 minutes. So you see 0 to 4. 0 to 4. So let me go into my machine and see if we can set up a cron that's going to run every 5 minutes. And then after 5 minutes, we're going to come to check, or we can even make it to run every minute. But anyways, admin user. Okay, clear. So I'm just going to VI in normal text. I'm just going to call it cron.txt. And I'm going to go in there and I'm going to come in here and say, okay, we have our 0 to 4. 0 to 4. So it means I want this to run, like you said, every 5 minutes. 0 to 4. And then everything else, I put star. Man, this machine driving me crazy. Back. And star. So there we go, 4 star. And now we're going to put our command. And what do I want it to do? I want this machine at this every 5 minutes. I want you to create to make a directory called Linus. And then for me, for this to be repeatable, there's a function I'm going to look online for date. That I can add a date on my machine so that Linux can know exactly what date it is. So what I'm trying to do now is I'm saying create a file called $date. Create a file in the name of Linus, and I want you to tag that file with a particular, with the date at that time. So that's essentially so we can have multiple files that are running, and we can also have the date of the file. So let me just make sure that that command is running. That command will run, and I don't want any errors right now, guys. So this is essentially, so if I wanted just my name, create a file called Linus, I won't do that, but you can start to see how you can. What's wrong with my keyboard? Create a file every 5 minutes. I want to create a file called Linus. So that's a basic command, and then I'm going to do our normal save. And then I'm going to save it. So that should run every 5 minutes. That's the plan. And then to activate it, all you have to do is just put cron tab, and then you put the name of that file. Is that easy? Cron tab the name of that file, and automatically cron tab already, automatically adds that file. So to list that file, to list all my cron commands, this is a cron tab -L. So cron tab -L should be able to list all my commands that I have in my cron tab. So you see, that is already automatically in there. And one thing I want to keep in mind is I hope that I don't have to put that in quotes, because sometimes you have to put it in quotes. But anyway, good thing is we already have that in our cron tab. If I wanted to edit, I'll use cron tab E, and it's going to open my cron tab for me, and I'm going to edit it. So let me see, cron tab -E. You see, when I put cron tab.E, automatically opens that file, and it opens that file for me to edit. So now I can edit and do changes. So the first change I'm going to do is I'm going to make D, I'm going to put all of this in quotes. I'm going to pipe this in. I'm going to save this into, I'm going to put all of this in quotes. That's the first change I'll do, just to make sure that my command doesn't fail. I'm going to put all this in a double quote. And then I'm going to make this directory Linus in, what I'm trying to do is I'm trying to make it directory Linus in my home directory. So I'll add that in here. So for home, I could put home admin user, but another shortcut is to use this. The little thing that I forgot what you call it, but it looks like it's on every dashboard, it looks like a snake, pretty much. That's how I call it. I call it a snake. But that's a short form for -home -admin user, your home directory. So I'm going to escape, and we're going to continue. After 5 minutes, the hope will be that, this command was successful, and I have a directory called Linus in my home directory. So right now, let me make sure that my home directory doesn't have a directory called Linus. Okay, we don't have Linus. So the hope is that after 5 minutes, there should be a Linus in here. And another thing I could have done was to send the output of the file, the standard output to a file. So if the command fails, I think I should do that, so we could put some of the things we just practiced, So what I'm going to add is remember the standard output, where I could say if it fails, I want you to store this in a file. So even if it doesn't work, I could look at that file and say, okay, this failed because of this. So that remember the two, and I'm going to put error.txt. So this is good to add. Remember, I'm not going to be there when this thing is working. So I want to make sure that if it fails, I have somewhere to look and say, okay, why did it fail? So this keyboard is just over typing. It's just erroring. But yeah, you get the idea. So that's what I'm trying to do. So this is how you start doing smart, smart working on Linux in a smart way, in an efficient way. Because you're able to do things like this. So my machine is just over. So I'll escape. Remember, I'll escape without saving, just so that I can have my work when I come back. So that's leaving without saving, and then I come back and my stuff is still there. So that's the use of leaving without saving. So if you had an error, you could just quit without saving and then come back and continue editing your file without having to go through it all over again. So my machine is really slow, so it's over typing or under typing. But I hope you guys are following along. So I'm going to make sure that I can store the output. If it fails, I want you to store that in the file. I want to store that in the file so I can come later and say if I don't see Linus in my background, I should be able to see a file called error.txt that's going to tell me what happened. Why did it fail? So that's very important when you're running programs that you're not going to be there. So we'll see. I'll run this and we'll continue our class. And then after 5 minutes, I'll come here and see if we have a file called Linus in this directory. So that's contact for you. And then this is another thing we have to talk about. So when you're working with Ubuntu, there's something called package management. In any Linux system, Ubuntu, CentOS, Yum search, Yum is our package manager. And remember, I tried to use Yum and it was telling me I have to be root user. So to look for packages in your machine, you use Yum. To install new packages, you use Yum. For our current machine, if we're using Ubuntu, we use something called sudo apt. But if we're using CentOS, so it's Yum to install packages. And I'm going to do that real quick here in a minute. So for example, I need to be root user. So to search root user, you switch user, sudo, switch user, and then I'm going to show you how to install packages. So first thing I'll do is just update my machine or install. So Yum install htop, which is something I tried to use before and it wasn't present. So the hope is that when I run that, it's going to install that for me. So so what it's telling me now is htop wasn't found. So it's not telling me it couldn't install it. It's telling me htop wasn't found. So keep that in mind. So this is how you install programs on Linux. Let me try Yum install. Let me see if we have curl and see if it's going to install curl for me if there's no curl already. You see? Now it's going to install curl for me. So if I put yes, I say why. Now it's going to automatically install curl for me. Why? And I'll show you how to bypass these Y's that I keep putting on. I know there's a way you can bypass it, but see, it's installing the program for me. So this is how you can install any kind of program. So now I have curl. If I run curl, you see, now it's telling me, you need the manual, you need this. So curl is currently installed on my machine. So that's how you install programs. Let's find another program. Let's see what other program can I install. Let me try another program to see if we have. Let's see if we have YGet. Yeah, we have YGet. So let's see another Linux installation, another Linux program we have. I know htop is not there. Another thing you can do is you can use it to update your system. So you can say Yum update. And then to bypass the Y that I keep putting, you can put -Y. And what you're telling the machine is, don't ask me to put yes. I'm saying yes for everything. So this will help you, especially when you're writing scripts. You're not going to be there, and you're writing scripts, and those scripts are going to do installations for you. Most of this installation, you won't do it. The scripts will be doing it for you. So you're not going to be there to say yes. So how are you going to do that? So you're just going to use this -Y, and you're telling the machine that don't ask me for yes. Just go ahead and install it, pretty much. So that's essentially what I see. It didn't ask me for yes. Normally, every installation, it will ask you for a yes. But because I used -Y, it didn't ask me for yes, just went ahead and installed it. So that's a nice trick. Keep that in the book, guys. Keep that in the book, class. So yeah, I'm teaching you all the little tricks in Linux. So we have our update, is updating our system, doing all the updates, keeping everything recently. So you can run that. It takes a while to run. You can always cancel it or terminate it with Control-C. But it's always nice to always update your system, to always make sure it's up to date, you know, and things like that. So this is what this command does. So we're 8:05 right now. You know, I'll just look through the slide to see what we have left. We've covered a lot. And the idea is that next class should be our last class talking about Linux. And we should be able to talk a little bit about Python next class. That would be my idea. Maybe a little bit about Python. But yeah, we're getting close to what we wanted to cover for Linux. Go back, practice, and we'll do more next week. On Saturday, we'll do more Linux, and then we should be able to wrap up Linux on Saturday and start doing something new. So my system is updating. Sometimes this will take a while. So let me go to the questions and see if I can address any questions, if there is any. Oh, there's no question. Any questions? Class is quiet. Any questions, class?
None for right now from me.
You liking what you're doing so far? Any feedback?
Not right now.
The way everyone is quiet, it looks like Linux is starting to.
Everything going good, but we just need to practice more.
Remember to practice. That's the key.
We need to watch that video and follow those commands. Yeah, we need to watch the video and practice more because I mean.
Yeah.
The way you're doing it, it's kind of interesting, but to follow up, it's hard. Yeah, that's it.
That's the key. By tomorrow evening, usually when I wake up in the morning, I wake up every morning around 5 a.m. And the first thing I'll do is to edit the videos and upload them. So by afternoon, you should have the videos. That's saying I wake up my regular schedule. But tomorrow morning, 5 a.m., I play basketball, I come back. But by afternoon, evening, you should have that video. So just practice. Saturday, we'll wrap up Linux, and then we'll start doing a little bit of fun Python. But you have to make sure you practice and just do the commands that we did. Go through the slides, follow the slides. Everything I'm doing today and everything I'm doing next week, I keep adding it to the same slide. So you can even go ahead if you wanted to and just look at the commands and just practice them before class. And you'll be good to go. So anyway, I think I should stop here. We've done a decent amount. We've covered a lot.